in 2016 ISA. I have not added many things here, but it is really honored to have Dr. C.B. Bhatt sir with us. And over to you, C.B. Bhatt sir.
Uh, Very good morning to one and all. It's my pleasure to have a talk with you. Before I start my presentation, just I mention that if it, if possible, we'll make these sessions interactive, and when we'll be using a online tools, how to implement the interactive sessions, it's a challenge. So, in case of Microsoft Teams, there is a provisions called raise your hand. So whenever I ask questions and pause for some time, I'll ask you to raise your hand, and I'll ask particular fellow by his or name, and he may put his ideas or thoughts, and maybe he tries to add some discussion point. So let me start my presentations. Once you uh, see the slides, just let me know. I think now it is visible to you.
Yes, sir.
Yeah. So the today's topic of this talk, it is online tools for teaching, learning, and assessment, and particularly in context of MBA. So my presentations, it will be something like this. First of all, we are talking about online teaching and learning and assessment. Uh,
Sir, may I interrupt you, sir, please?
yes.
Sir, there are distortion in your voice. Can you adjust, please?
Hello.
Sir, there is distortion in your voice. We cannot hear clearly. Can you adjust it?
Yeah. Hello.
Yes, sir.
Now, how is the quality?
Now it is just better. Okay, sir. Continue, sir. Thank you.
Okay. The presentation uh, outline, it is something like this. Uh, what is educations? What's really engineering educations? How it has been evolved over a decade, over a centuries. Then accreditations process, and why this various pedagogical instructional methods we should look for that, and why online tools are important in this context that we'll discuss. So uh, I know that this is a faculty development program. So we all learn. We have already learned many things. We all learn. We all teach also. We are a teacher, and we all keep learning because the technologies keep on changing. The way we perform our task is keep on changing. So naturally we need to keep learning always something new. And online teaching and learning and online assessment, it is one aspect of that. Um, but many times while doing all this, we hardly reflect on really what is education, what is learning, what is teaching, and it is not only problem, or we can say it's only our issues with our institutions. It's a universal university paradox, and many times in educations, people's they never thought of what is real education is. What do I mean by holistic development? So Actually, few beginning slides, it will be talking about this, and it is also very important in context of MBA also. So we can say education in the general sense is any act of experience that has a formative effect on the mind, character or physical ability of an individual. So it talks about three dimensions. That is one is mental development, another is character development and physical ability developments. And as a part of our education system, basically what we do, so since many generations, we have gained knowledge. We have developed a body of knowledge in various domains, like knowledge we have acquired since centuries by our ancestors. Similarly, skills also, values also, and all this knowledge, skills, and values we are interested to impart to our next generations. So, from generation to generations, we are interested to transmit the knowledge, skills, and values we have acquired, and our purpose of education system is to transfer that knowledge, skills, and values to the next generation. So that is what the education system is. So here we talk about uh, actually the holistic development. So we talk about mental development. We talk about here you can see the mind, character or knowledge, values. So that is cognitive mind. It relates to mental development, cognitive domain. Then values or attitude that relates to affective domains, and uh, abilities, physical abilities. So that is a psychomotor domains. So basically, this is what we talk about any times, every times when we talk about say holistic development, then basically it's a development in all the three dimensions. So nowadays we are talking about outcome-based educations and disciplines, uh, various disciplines like computer engineering disciplines or civil engineering discipline. So if you look at the word sister and sisya, then sisya and sister, both the words are derived from the root called sas. That is in Sanskrit it is called dhatu. In English we call it root. So the root of sisya and sister both are same, that is the sas. Similarly, interestingly, if you look at in case of English, it is in Latin disciplinia. It is the root of this discipline and disciple, and that meaning is that is to training the corrects, molds, and perfect the mental faculties and moral character is known as a discipline. So that disciplinia, and in the case of Sanskrit sas, it talks about molding the behavior, mental ability, physical ability. So here, discipline, it's not simply a good behavior. Good behavior is one part of discipline, but there is something called a discipline-specific behavior. So if we talk about say civil engineering, then civil engineers, when they perform their task in field, they have to behave in a particular manner. So there is something called a discipline-specific behavior, and that's the reason actually we are calling say disciplines like civil engineering disciplines, electrical engineering disciplines, something like that. Uh, Now, if we talk about say shift in engineering education, there is one interesting article in IEEE, 100 years of engineering education, and there they have mentioned about there were major five shifts in engineering education. First shift, we can say it was initiated after in engineering faculty after World War II. So actually, if we look at historically, then engineering education initially it was imparted by apprenticeship method. So in case of apprenticeship methods, the disciple or student, he tried to imitate, he tried to copy the behavior of master. Particularly apprenticeship-based educations having a more focus on skills development. So whatever the task performed by masters, it will be imitated by disciple and try to master the task. So we can say that the education, it was transformed through practice. During the World War II, we found many applications of automation systems like automatic gun missile systems, aircraft systems. So people across the globe, across the world, they thought that we need to have a more focus on science, and we have to have a applied science in case of engineering educations. So the shift was taking place from more practice to more study of scientific theories and mathematical studies. Uh, at the same
Sir,
time,
your voice is not audible.
hello, hello, hello,
Sir, there are a lot of distortion in your voice. We cannot clearly hear your voice.
hello,
Sir, we cannot clearly hear your voice.
hello.
Uh, Hello, sir.
Uh,
There are distortion in your voice. We cannot hear clearly.
just a moment.
Sir,
Let me.
actually, there is a lot of background noise in your audio, sir.
Sir, your voice is not audible.
Hello, hello, hello.
Uh, Hello,
Hi, sir.
Chetan sir.
Uh,
Yeah, I think your voice is actually audible, but there is a lot of background noise. I think might be the sound of your fan. That is might be your
fan,
PC motor or something like that. That
fan
is
is
causing the background noise.
fan is off.
Your laptop or PC, sir. I think in that the CPU fan, probably something like that. There is a humming sound.
Just a moment. Uh-huh. Just a moment. Check. Hello. Now,
Hello. Hi.
uh,
Yes, sir.
Yes, audible, sir.
now it is clear. Hello.
Hello, sir.
Yeah. Now
No, sir. It is not still not clear, sir.
so we are able
Actually,
to
sir,
hear.
I
Sir,
think you, the
speaker
mic has
on us.
got some problem, sir. That particular
Yes,
Yes,
case,
sir.
the mic, probably you're using the headphone you're using, it has got some problems, sir. What I feel.
Hello.
Right, Burman. Right.
Taru. You know. Hello. Hello. Hi, Karigo. Ha. Hello. Now it is.
हेलो
હવે આવે છે બરાબર.
एकदम परफेक्ट सर एकदम
Okay. So there were five shifts in engineering education has been observed. First shift, it was post World War II, that universities across the world, they have started focusing more on science and mathematical studies. And during the same period, Russia has launched Sputnik, And education institutes and government in US, they thought that they need to uh, actually reform the education system in the US. And they have constituted one committee under the Bloom, that we all know the well-known Bloom's taxonomy. So under that Bloom leadership, uh, they have developed the taxonomy for cognitive development, and subsequently even various Bloom and other groups, they have developed the taxonomy for affective domains and psychomotor domain also. And education system, particularly in US, and particularly at school level, they have started applying the concept of that is something called outcome-based approach, or we can say introducing the learning objectives in teaching and learning and assessment. So that was this shift post World War II. And actually the same it was followed by India also, and universities across the world having a more focus on science and mathematics. After few years, it was found that students learning in engineering education institutions, they know theories well, but they are not good engineers. They are not good at practice, and they are not good at design. So people, they thought that real engineering is to design a solution. So particularly the beginning in MIT, they started design course in 70s, having a focus on engineering design. Once we have a focus on design, then it is observed that students, they have a lack in experience, expertise in performing practicals, and understanding the other dimensions related to engineering design. So the next set, it was the, we can say fourth set, it was the introduction of accreditation systems. So people, they have introduced the accreditation systems when we have a well-defined criteria, we can say program outcomes, or well-defined graduate attributes of engineers, what engineers should be able to do. Not only there we have a focus on mental development, but other dimensions related to engineering activities, it was also there. And universities across the world, they found that once we try to address all these attributes, if we want to develop all these attributes in our students, then simply the conventional way of teaching and learning, it will not help. And we need to introduce a new pedagogical approach, new technology in our teaching and learning to address all these dimensions, graduate attributes. So we can say that the outcome-based educations plus ICT applications in teaching and learning, and new research in pedagogy, that is in particular in cognitive science, in instructional theories, all these applications in teaching and learning are now being introduced in engineering institutes across the world. And so we can say that outcome-based educations, that is the accreditations, ICT-based applications, and applications of pedagogical research are now being applied in engineering institutions across the world. So actually, today, if we talk about engineering systems, then it is not a simple engineering systems. Today we are talking about the complex engineering systems. We can say it is a systems of systems. Suppose if you consider, say, smart grid, then it's not simply electrical transmission lines. It covers many other systems also. If you consider, say, mobile communication system, then it is not simply communication systems, but it is a very complex systems of systems. So nowadays we are talking about a very complex engineering systems, and that involves interdisciplinary approach. So it demands a courses from other domains also, and not it is not simply other domains means technical domains, but even humanities and social science and other domains also becomes very important when we talk about the complex engineering systems, solving a complex engineering problems. So the questions comes really, what is engineering is? Can anybody answer this? What is engineering? You can raise your hand. Hello.
Hello.
Yeah.
Sir, it is the applications of scientific knowledge for the benefit of the society.
So application of scientific knowledge to benefit.
Scientific knowledge for the benefit of the society.
For the benefit of society. So it talks about here our concept is application of science. So the main task of engineering is to find and deliver optimal solutions to real life problems. So application of science for benefit of society. So that means that in a real life we have a problems and we want to solve that. So to solve that problems, what we do is we actually apply the scientific, technological, and engineering knowledge. Now, what type of solutions we have to provide? We have to provide optimal solutions. So, optimalities of solutions we can define against various constraints. So, while providing the solutions as an engineer, we are working under various constraints. So what are the constraints? We will have a given materials, components, technology, economical constraints, societal constraints, environmental constraints. So working within the constraints, we have to provide optimal solutions. And that solutions we have to provide through the application of scientific, technological, and engineering knowledge. So here it means that here I have categorically here written the technological and engineering knowledge. There is a difference between technology and engineering. What is the difference? What is the difference? Hello. What is the difference between engineering and technology?
Hello.
Yeah.
Sir, engineering focus is more on the research work, while technology is related with applications of different technology.
Yeah.
So engineering is, I can say it's a knowledge technology which we actually use in real world where applications.
Correct. So technology, it's a well-defined approach or procedures we need to follow, or we can say rules also. Rules and regulations and procedure we need to follow to solve a problem. By engineering, it's a, we can say body of knowledge where it goes beyond the well-defined rules and regulations and approach. So suppose if we say 2G, 3G, all this are technology. So building technology, suppose if we say, if we have to build building something like our house, then nowadays it's a well-defined way of approaching the building, approaching the solution. So if it is a well-defined process, well-defined rules, then we can say it's a technology. Well, engineering, it's a very large, it includes the technology, but it is beyond that well-defined approach. So we need to bring many other dimensions, and basically we can say it's a body of knowledge. So It means that the main task of engineering is to provide a solution to real life problems, and every engineering activities involves many constraints. Engineers, they are working under constraints, and they are using scientific, technological, and engineering knowledge to solve a problem. Basically, engineering, it's not simply applied science. Normally, we say that it is applied science. Of course, it is we are applying a concept of science, but as an engineers, we need to think beyond science also. Suppose if and even if we consider the history of engineering, history of technology, then many times we found that the root of development of theory, it is not theory. Basically, when we talk about, say, applied science paradigm, then theory is there and we are using the theory to solve a problem. That is what we call the applied science paradigm. But suppose if we consider the history of technology, engineering, then steam engine, suppose if you take as an example, then steam engine was developed well before the laws of thermodynamics are developed. Aircraft was developed well before the laws of aerodynamics are developed. So we find many such products in history which are developed well before the background theory or background knowledge how it works it was developed. So it was the actually the curiosity and attempt of the inventor who intuitively applied those concepts, and later on scientists, they try to understand the underlying principles. So many times it is found that through experimental studies, people, they have developed the products, not simply by just applying the science and mathematics. But today, actually, what we'll be doing is we have a well-developed science, mathematical concepts, and initially at the beginning we prepare some scientific mathematical model, and based on that we try to solve the problems. So in some sense, in majority of the cases, the applied science concept, it works, but sometimes it happens that we will need some knowledge which can be gained through experimentations also. And background theoretical knowledge, it is not available. Another dimensions, it is not just not simply applied science, is that as an engineers, when we try to solve a problem, we need to think of society, we need to think of environment also, we need to think of the available materials also, and under all constraints we have to work. So simply that is not covered under the science. We can say we need to think beyond the science also. So what do engineers do in general? So in general, if you look at, then as an engineers, we conceive the idea, we have some intention to do some work, we perceive the problem, we identify the problem, then we design. As a part of design activities, what we do, we plan, we assemble something, we try to simulate something, we create and then test it. So that is the design phase. Implementation phase is we put it the whatever the product or systems we have designed in operation. During the operations, we maintain it, we repair it. That is the implementation phase. And there is something called so normally every product, every system having a life cycle. So at the end of the life, we need to even think of waste management also. So mostly, actually, we are not training our students to think of what will be the product, how it can be regain the materials used in product, how we can recycle. All such dimensions we are not teaching. We may teach design and implementations part, but how to identify the problem, again it is missing. How that at the end of the life cycle, how we should handle the products, that is missing. And it means that as an engineers, we should look at all the dimensions related to product development. So, the very beginning from conceiving to the ultimately the waste management. Here, simulation, it is one measure in design, and particularly we are talking about online teaching,
Sir,
where it's a
sir,
very
sorry to
important
interrupt
role.
you.
Yeah.
Sir, participants are writing in chat. They are not hearing clear voice, and really there are a lot of distortion. Please kindly solve this issue, sir, please.
Yeah, just wait.
Yes, sir.
Hello.
Yes, sir.
Hello. Huh. Uh, Now, how is the quality?
No, sir. Still, some humming sound is there.
I am joining through other device also. Just let us check. Hello.
Yes, sir.
Now,
Now, sir, it is clear.
okay.
Yes, sir, please
Much
continue.
better, sir.
Thank you, sir.
So, as a part of design activity, simulation nowadays, solving engineering problem is at the very beginning, we prepare a mathematical model and we try to simulate. Uh, so, what is simulation, by the way? What is simulation? Anybody can answer?
Simulation is the virtual run of actual system.
Simulation, it is a virtual run of actual system. So we have a mathematical model of a simulation, and we try to implement the systems virtually using some mathematical model in a computer, using some computational tool. And simulation offers many advantage also. So if we have to run number of runs of a experiment, then simulation will save our times. Even it is economical also, because physical components we need not to have, and it avoids the damage also. So if we are performing some experiments and some unsafe situation is occurred, then it is very harmful to systems as well as the operator. But in case of simulations, there is no damage. So it means that it is economical also, it saves our time also, but uh, there are many other advantages, like in engineering we are dealing with dynamic systems. uh, so there are systems having a very large time constant, like suppose if we consider say ecological system, if we consider say biological system, where observable output, it takes years to number of years to have some observable outputs. So in that case, if we have a well developed mathematical model available for such systems, then it can be easily simulated. We can observe the outputs of a systems with given input or disturbances. So we can say that using simulation we can compress the time. Suppose if we consider say in biological system our aging, today if we look it in a mirror, and if tomorrow if we look it in a mirror, we cannot detect the change in our face. But if we can if we see our 5 years old photographs and compare with our today's face, what we see in our mirror, then naturally there is a detectable change. So it means that biological systems, ecological systems, it takes very large time to have some detectable change, and the simulation will help to compress that time. Similarly, if we have a distributed systems nowadays, suppose we have a very large distributed engineering systems, like Narmada Canal water distribution systems or smart grids, then such systems
तो
are
जो है
such systems are distributed across the space.
બીજા કોની વાકે છે આ બધા આ જે પાર્ટ ને તાર તારા નહીં રહી લગે હોય.
So if we have a very developed mathematical model, then naturally we can study the response very easily. Suppose let us say if there is a 10% opening of gate at Narmada Dam site, then what will be the level change at the canal located at Rajkot? Then performing such experiment in a real life, it is very difficult physically. But if we have a well developed mathematical model available, we can easily study if we have a 10% opening of the gate, what will be the level change at these particular locations. If we have a 5% gate openings, then what will be the level change. So it means that if it is a distributed system, then study it is very easy. So we can say we are compressing the time and we are compressing the space using the simulations. So we can say that we have a very we are creating a physical world, we are operating it, and we are ultimately managing it. So it means that as an engineer, what attributes we should have, or what attributes students should have. So that is where the Washington Accords, or in our case, in case of India, they have defined a program outcomes. Now it is known as a program outcomes. There are 12 attributes, or we can say program outcomes, defined by MBA. One is engineering knowledge. Now, if you look at the Bloom's taxonomy, then it starts with recall, comprehension, apply, analysis, evaluations, and synthesis. So you can see that the first two, recall and comprehension, this graduate attribute, it starts with apply. So apply itself, it requires a recall and comprehension abilities. And actually in education systems, we have to address the higher order thinking skills. When for engineers, higher order thinking skills, critical thinking abilities is very important. And here, if you look at the graduate attributes, it starts with apply. You can see the analysis, then evaluations and designs. So it says that apply the knowledge of mathematics, science, engineering fundamentals, and engineering specializations to complex engineering problems. Then it comes problem analysis, identify, formulate research literature, analyze complex engineering problems, and reaching substantiated conclusion using first principles of mathematics. Now here, say formulations of problems required applications of mathematics and simulation tools. Research literature, nowadays the searching the literature systematically online, it is a even a very important skill, where we can find a authenticated literature. It's really important. And nowadays there are many online portals, online services are available where we can find a such literatures. Design solutions for complex engineering problems, and design system components or processes that meet the specified needs. And here, see, designing the solution with consideration of health, safety, cultural, societal, and environmental considerations. So it means that as an engineers, when we design a solution, we need to consider the health aspects, safety aspects, cultural aspects also, societal aspects also, environmental aspects also, while designing a problem. So it is not simply a engineer should know only the science and maths, but they should know even cultural aspects also. Suppose if we are designing, say, human machine interface, then actually the design of HMI depends on cultural background also. Suppose if we are designing for say for Indian context, then we used to read from left to right and top to bottom. But if we consider say Middle East countries, Persian or Arabic, then they read from right to left and bottom to top. So and in fact their mind is trained such that even if it is a graphical representations, in case of India we look from left to right and top to bottom, but in their case it is different. So it means that the human machine interface we design, even as an engineers we should know for what cultural backgrounds we are developing the application. Similarly for societal dimensions also we need to consider. Nowadays we are talking about the inclusive design. So inclusive design means considering the cultural dimensions, societal dimensions, gender dimensions, abilities dimensions. So considering all these aspects, we need to design a solution. Now it talks about conduct and investigate complex engineering problems. So there actually again research-based methods, including designs of experiments and all it talks about. But modern tool uses, this is the create, select and apply appropriate techniques, resources and modern engineering and IT tools. Now if we talk about say this first five modern tool uses and this two and this actually first five attributes, then we can say it is related to technical aspects. But after this fifth attribute, rest of the attributes defined by Washington Accords or NBA uh, are not, we cannot say it's a technical, only a technical dimensions. It is a non-technical dimension in context of technical technology. So we can, the engineers and society, so apply reasoning informed by the contextual knowledge to access societal, health, safety, legal, cultural issues, and the consequent responsibility relevant to the professional engineering practices. So it means that it is other than science and technology, other dimensions, we need to sensitize our students. Similarly, environment and sustainabilities, understand the impact of the professional engineering solutions in societal and impact of the professional engineering solutions in societal and environmental context. So, understanding of societal dimensions, understanding of environmental impacts. Say at the beginning, I was talking about say at the end of the product life cycle. Basically, every development of product and systems, it has a environmental impact at each and every stage. Suppose if we consider say at the design stage itself, the type of material we select to design a product, it has an impact at the production stage also. It has an impact at the implementation use stage also, and at the end of the life also it has an impact on environment. Suppose if we consider say let me ask the questions. Let us we consider say mud pot. Can we consider it's environment friendly? Mud pot. Hello. If we have a mud pot, can we consider it's environment friendly?
Yes,
Yes or
sir.
no? Yes. So many times we think that such products are environment friendly. So when we talk say any product or system is environment friendly, or we can say eco friendly, it depends on at what stage we are talking about. Suppose if we consider a mud pot at the use stage, it is environment friendly. Even if we consider it's at the end of the life, it has no that harmful impact on the environment or ecosystems, but it has some impact. And at the manufacturing stage, to produce a mud port, what we be using is a fire to make it pakka. So it means that the fire is used to prepare the mud pot. It has an impact on environment. Uh, so we cannot say mud pot it is 100% eco-friendly product. Some of the product, so of course at the usage stage it does not have an impact, but at the end of the life we throw it in a soil, and it will not disintegrate in a soil. That mud pot will. That is the reasons we are finding terracotta items in Harappa and Mohenjo-daro sites. So it means that every product it has an impact on environment at the stage of productions, at the stage of uses, and at the even after the life of product or system itself. So uh, actually the type of material we select for a product, accordingly we have to use a production process, and that production process is an impact. Suppose if we consider say electricity generations using thermal power plant, then at the production stage itself it has a very high impact. Suppose if we consider say nuclear power plant, then the material we'll be using, it is a very harmful materials we'll be using. It has a during the operations stage also it has an impact. Even at the after the end of the life of the radioactive materials, we cannot just throw it like that. So at each and every stage such products it has a impact on environment. In case of mud pot, of course it does not have a very harmful impact, but it has a some impact. So suppose if we talk about the plastic material, so at the design stage itself we can say my product packaging it will be made up from plastic. Then it means that I'm not considering the impact of plastic on environment, but I can say that if instead of plastic, suppose if I can say I'm using a aluminum packaging uh, which I can use in my product, then it means that by considering the impact on environment at the end of the life, I am considering and I am selecting aluminum as a material. But if we use aluminum as a material, then what is the impact at the production time? That also we need to consider. What is the impact of uh, production of aluminum on environment? So there are many dimensions we can consider. Based on that, this environmental and sustainability of a solutions we can think of. Similarly, ethical aspects. So ethical, that is the general ethics as well as professional ethics, individual and teamwork, communications, communications, oral communications and written communications, and communication through diagrams. That is very important. Project management and finance, and lifelong learning. Now, if we look at all these attributes, then naturally, how we can develop understanding of environment and sustainability, how we can taste, develop ethical dimensions, how we can develop the communication skill. Just having a one communication skill subject in our curriculum, it will not solve this purpose. How we can develop the project management and financial abilities, how we can develop the lifelong learning abilities. So is it possible that just by using the conventional way of teaching and learning will help us to develop all these required abilities in our students? So answer is no. So for that, actually, our conventional way of teaching and learning also we need to change. Conventional method also we need to change. So there is something called research in pedagogical dimensions. That there are so much of work has been done in this area also. So there is something called a collaborative problem solving approach, 4-component instructional design methods, constructive learning environment. So learning by doing, learning cycle of star legacy, instructional episode. But in general, if we consider all these theories, it is based on, there is something called a constructivist learning theories. Uh, so there is something called a behaviorism, there is something called a cognitivisms, and there is something, there is a theory which are classified under constructivism. So behaviorism's theories, cognitivism's theories, and constructivism's theory. So in brief, if I say behaviorism, it says that by uh, award and punishment you can reinforce the learning. So that is so suppose students is performing well, if we reward them, then that will improve the learning. If they are doing something wrong, their behavior is not acceptable, then we punish them, and that's the reason that uh, unwanted behavior, it will be slowly changed to what is the required behavior. So that is the behaviorism approach. Cognitivism approach, it says that human, they have a mind, they can think, and they can construct their own meaning of the concepts, or own meaning of the experience they have. And constructivist, it says that they, everybody, they have their own experience, and based on that they have their own mental map. They perceived same thing, every individual perceived same thing differently based on their constructions of experience, constructions of mental map. So based on that, that first principle of instruction, it says that our teaching learning is facilitated when the learner is engaged in solving a real life problem. So when our students, they are involved in solving a real life problems, they are feel they are engaged. New knowledge builds on learners existing knowledge. So everything, our whatever we understand, it depends on what is our existing knowledge is. Suppose if we can, even based on our perceptions, we understand. Uh, Say suppose in systems dynamics, we say that gain bandwidth products remains constant. In electronics amplifier, that fundamental one of the principle is that gain and bandwidth products of analog amplifier remains constant. Uh, so suppose if we consider, say, it is in electronics amplifier. Suppose if I consider, say, our vocal system, then vocal system itself, it's a one amplifier, it is a pneumatic amplifier. There also the same concept should apply. So it means that if I have a knowledge of our vocal systems, I can apply the same concept also. I can apply the similar concepts in other domains also. So depending on my existing knowledge, I try to interpret the theory, I try to interpret the concepts. New knowledge is demonstrated to the learner, then learning will be facilitated. If we provide the scope of applications, then knowledge is facilitated. New knowledge is integrated into learner's world. So if they apply in their own way, in their own life, then actually learning is facilitated. So these are the basic first principles of instruction. So basically it says that first of all we should start with activations, then demonstrations. Say as a teachers, we have to correlate with that existing knowledge. We should bring some real life problems. So this is that the center, there is a problem. Activations, it is through existing knowledge. So we should try to link it with the existing knowledge. Then we should demonstrate them. So we should demonstrate them. We should provide them opportunity to apply, and then they have a integrated in their own way. They have a well understood uh, concepts, and they try to understand on their own way based on their existing knowledge. So this is how this first principle of instruction it works. So it means that at the center there is a problem. So it means that if we want to address all the 12 attributes of NBA, then we need to focus on problem-based learning. So problem promotes the acquisition, elaboration, and use of mental models rather than only associative memory. So that we'll see the brain uh, part later on. I'll show you. Uh, actually, when someone is involved in a problem solving, then it is not only the associative memory is involved, but uh, all the whole brain it is involved in activity, and that's the reason we can say that learning is improved if we follow a problem-based learning approach. So activation, so learning is facilitated when relevant previous experience is activated and learners are directed to recall, relate, describe or apply knowledge from relevant past experience that can be used as a foundation for the new knowledge. So how we can provide activations? So are directed to recall, relate, describe and apply knowledge from relevant past experience that can be used as a foundation for the new knowledge. Are provided relevant experience that can be used as a foundation for the new knowledge. So activates a mental model appropriate for restructuring or tuning the new knowledge. Uh, so this is all theory, and why I'm putting over here, that is why we need a online learning. And this is the basically I'm preparing a context for that. Now demonstrate. So learning is facilitated when the instruction demonstrate what is to be learned rather than merely telling information about what is to be learned and when. So if we can demonstrate example and non-example of the concept, demonstration for procedures, visualization for procedures, modeling for behavior, all these are the demonstrations. The consistency criterion should be applied first. If demonstrations are inconsistent, then it does not matter if there is learner guidance or if the media is relevant. So it means that you have to demonstrate that what the concepts you are discussing. Now the questions comes here. I have a total 12 dimensions, graduate attributes, uh, ethics, lifelong learning, all this. Is it possible that by offering a one single course related to professional ethics or communication skills, we can develop such abilities? No. We have to integrate in many courses all these dimensions so that these abilities can be uh, addressed. Now, as a teacher, we don't have sufficient time to do that. Then what is the solution then? How we can do that? We are, suppose if we say that if we have a formative assessment, then and at the end of every lectures, if we can have a what the students have learned, then we can easily plan our instruction. We can improve our teaching and learning. So do we have a that much time, that much resources available with us? If we have to have provide a immediate feedback of formative assessment, then do we have a time to assess their answer sheets? So answer is no. So it means that we need to use a various tools which are useful for our teaching and learning and assessment purpose, and that is where the online teaching and learning comes into picture. So application is parts of practice, kinds of practice, how to practice, do the procedures, what happens practice, that is a predicted consequence of a process. So as a part of applications, these are the various aspects we can address: recall or recognize the informations. Part of practice means locate, name, and describe each parts, identify new examples of each kinds, do the procedures, predict a consequence of process. And it means that at the very beginning, we are starting with a problem. As a teachers, we pose a problem, we ask students to answer, and we have to analyze the uh, responses given by students, and based on that we have to deliver or provide instructions. So it means that implementing a problem based learning, it is not a simple task. It is a very complex activity that we need to plan well before the session starts and implement it. So based on this same problem based learning, uh, so it says that experiential learning, it says that if you provide a concrete experience and ask them to reflect on their observations, and then ask them to conceptualize what they have observed and involve them in active experimentations, it will improve the learning. And I was talking about a whole brain activities. So how our brain work, then actually through our sensory elements we sense. So basically this is the sensory and photosensory dome lobe, where all our experience through senses we gain. So that is the concrete experience. Now in temporal integrative cortex, that is what we call the reflective observations. Based on our senses, our this part of the brain, it provides the reflection on it, what we have observed. Now our frontal lobe, that is actually the abstract hypothesis. So it tries to integrate, it tries to associate with our past memory, and that is what we called a abstract hypothesis, or we can say integrative cortex. It is the function of that. Now what active learning it do, active learning activities do, then it tries to involve this premotor and motor context also. This lobe of brain also, it gets involved. So mostly what happen is, in our conventional teaching and learning, we receive and we try to even reflect on it. If it is not associated with the past experience, past memory, then this part it is not involved. If it is not, students are not actively involved, then this part of brain it is not involved. So mostly in case of conventional teaching, that sensory and post sensory activities and some at the somewhat extent integrative cortex are involved. Rest of the brain, it is not involved in the learning activities. So problem based learning, or we can say active learning activities, all tries to involve the whole brain in a learning, and that is the advantage of various active learning approach. So effective learning, that is having a concrete experience, it is followed by observation of and reflection on the experience, which leads to the formation of abstract concepts, that is analysis and generalizations conclusions, and used to test the hypothesis in future situations, resulting in a new experience. So if all these four activities are integrated in our classroom activities, in our teaching and learning, then it helps improving the learning. So how we can incorporate this at various program outcomes level? So mostly engineering all teaching methods, we can say it is used. In PO2, give students lecture courses, real or simulated experimental data to analyze and interpret. So for this particular cases, we should use the simulation tools, realistic experimental error into data and sometimes gives experimental results that contradict theoretical expectations. So here we can give some experiment, real experimental error as a part of data and try, we can ask them to analyze it. What could be the problem? So fault analysis activities we can give here. We can give the experimental results that contradict the theoretical expectations. Theoretically, this is what actually we should have, but these are the data experimentally we have received, and it contradicts the theory. So what could be the reasons? So include problems related to design of experiments in the classroom exercise. Here, if design and all this, include design methods in lectures, design problems and courses throughout the curriculum. Early in the curriculum, provide constructive feedback, models of good responses to these problems. So you should develop some solutions model, and when we talk about say complex problems, then that is the real design problems. Many times faculty members, they have a misconception that uh, if we use the word design, it includes the design. No. Suppose if I say that design a controller, and designing a controller involves a well-defined process and steps, then it is not in a real sense it is a design. It is simply applications of a design algorithms for a given situation. That's it. It is not a real design. So when we say design problems, it means it has a multiple solutions. If the design problem, if the problem having a one simple single solution, then it is not a design solution, design problem. uh, so actually you should have a good designs also for a given problems. Provide study guides with learning objectives that deal with easy aspect of processes used to solve the problems. So actually all this you should convey. Learning objectives, it should be conveyed in words. So it means that in a 1 hour time, I don't have a sufficient time to convey all this, sufficient time to provide the study materials, because uh, design design skills you can develop. Design skills you can develop if you provide them not only the spoon feeding, but you provide some reference material to study. It will help to develop their design abilities. At the same time, it will help to develop their learning abilities also. We are talking about lifelong learning abilities. There it will help. So conduct investigation of complex problems. So here run several open-ended experiments in engineering laboratory courses that call on the students to design and carry out the experiments to achieve specified goal. Ask students to use concept of design of experiments, device experiment to test hypothesis. So it means that they are actively involved in activities. Modern tool uses. So have students to use state-of-the-art technology for design, hardware and software, control, analysis, web-based research, writing and communications, use extensive simulations activities. Hmm. Now engineering and society, it is the very important dimensions. Use case studies that involve current societal, health, safety, legal and cultural aspects related to engineering problems. Suppose if you consider say Narmada Canal, then Narmada Canal, it's not say simply a technical problem, but it is a socio-political problem. Politics is involved, societal dimensions we need to consider. Say in a dam site, people they have to migrate, land acquisition, all these dimensions are involved. So if you bring such cases like say Bhopal gas tragedy, if you bring such case studies in a classroom, then we can say that engineering and societal aspects are being addressed in our teaching and learning. Similarly, for environment and sustainability also, we should use the case studies. Ethical case studies also we can bring in into our teaching and learning. Individual and teamwork. Assign projects that involve materials and methods from different disciplines. provide training to effective team functioning and all. So that dimensions we need to address. Communications here, writing across the curriculum and writing to learn methods. So writing across the curriculum means throughout the course or integrating the various course, how you can write some articles or some paper, how your procedural methods and all that can be expressed. So that also you can incorporate. Project management and finance, again, we can ask them to work on a small mini projects and various projects involving other dimensions also, and lifelong learning. uh, Now the questions comes, uh, to implement such pedagogy, say problem based learning approach and all this, do we have sufficient uh, time, sufficient resources to implement it? So as a roles in a team member, coordinator, they should schedule meeting, clarifies the role of team members, deadlines. They should record their team activities, coordinate the preparation of final solution set, lab reports, intermediate drafts, project reports. Some checker, they should have verify that. And finally, there should be some group process monitors also. So as a group activities, there are various tasks is to be uh, conducted, and we need to implement it. So as a teacher, our problem is we do not have a sufficient time, or if even if we want to implement it, uh, we need a resources. We need a resources. Using a pen and paper, it is very difficult to implement. How we can provide group activities, uh, and if it is a group activities, then we need to implement a criterion based assessment. Criterion based assessment means we need to use a rubrics. If it is if students they are working from remote locations, then how we can ensure that they will follow all the ethical practices, uh, how we can have a safe examinations, how we can even calculating the COPO attainment, it is very difficult. How it can be automated, how uh, assessment it can be automated. If we have to prepare keep the record of all, it is if it is a uh, harder form, then it is very difficult to keep it. So here, that is the these are the problems we have in context of the way we need to teach and learn and assess in context of NBA, and for that is the reason we should use the various online teaching and learning methods. So there is something called a learning management system, and there is another tool that is known as a safe exam browser. uh, Moodle, Sakai, there are many such learning management system. Moodle is an open source tool. Similarly, Sakai is an open source learning management system. OpenEDX, it is another learning management systems, and majority of them, they have a very good uh, tools, plugins available to implement various online teaching learning activities. Just we'll have look at the Moodle. I'll share my Moodle screen. See here, this is a Moodle platform. Uh, so here you can put all your course outcomes. So all the reference materials, the materials prerequisites they need to study before they come to class, they can that you can put it over here. You can actually plan your lesson over here. Suppose I'll say that create a new course. See here in course format, it there are various, say, e-task topic format, single activity format, social format, topic format, weekly format. Uh, this social format, basically, I was talking about constructivist approach. Now, today there is something called a social constructivism. Social constructivism, it says that if you are working in your peer group, you are learning. If you are learning in your peer group, your learning will be improved. And that also we have experience also when we discuss with our friends some ideas, some concepts, we learn better. So that social format, it says that uh, students learn better when we provide a sufficient scope of social interactions. So there we can use a social format. Single activity means if we want to want that students should work individually, then single activity format it can be done. Topics format, it means if we want to plan our teaching and learning in a topics format, like say topic 1, topic 2 in our syllabus it is given, then for topic 1 here it is not in ours. Similarly, weekly format, weekly, suppose if we have a 4 hours theory, then in weekly formats every week we'll have a 4 hours, and every hours we can plan. So like that, various formats it supports. Say you can say that grade books you want to generate or not, you want to generate activity reports of students or not, whether student how active students was in a particular activities, then it will generate the activity reports also. Then completion tracking. Suppose I have a topic 1. In topic 1 I have a 3 activities. Then how many students have completed 2 activities, how many students have completed 3 activities. So it keeps tracking of completion of activities by students, whether we want to provide a group activities or not. And that group, it should be force group mode, or it should be uh, students they can form their own groups. If it is a force group, then faculty can create the groups, and students they have to work in that. If we want to provide a various roles as a part of this course, so like this we can uh, create the course itself. See, as a part of resources, we can add book, we can add file, we can add folder. IMS, it is a learning standard actually. And IMS content package, course content package developed using IMS standards that can be deployed. This is a label actually. This label, engineering education MBA, it is a label. Page we can add, we can use a URL. So we can use the various different types of resources in advance. And even the concept of that, there is something called a flipped classroom. So flipped classroom means as a teacher, we provide video lectures and other reference study materials in advance. We ask students to study that and come in a class. In a classroom, what we'll do is we'll solve their doubts. We will solve their problems. That is what we call a flipped classroom. So in a classroom, actually, the activities we perform is problem solving, not the delivering of material. Delivery, it is through some materials, resources provided. So that can be easily deployed using this such learning management tools. We can provide all the reference materials in forms of books, videos, lectures, and everything. And in a classroom sessions, we can have a doubt solving sessions. So it's a part of activity. If I click over here in a part of activity, can you see the drop down? In a drop down, can you see this 360-degree feedback and assignments? Hello. Hello.
Yes, sir. Yes.
Assignments, attendance, chat, choice, database, e-voting. So there are many activities you can pose in a classroom. You can introduce in a classroom. Suppose say e-voting, even e-clicker, that there is a tool like in KBC, you will find vote by audience poll. Then basically it is a e-voting. The question is posed and members in audience, they respond to it. Similarly, in the class, you can pose a questions after at the end of your lectures or in between your lectures, and try to understand that what students have understood, what they have learned, and based on the response, you can modify your teaching. So that is what the e-voting is. So you can implement the 360-degree feedback, and in particularly in case of problem-based learning, what their ability to learn in a team, even you can ask questions to students to respond for their, to rate their peers. So there we can use the 360-degree feedback. Students give feedback to students. Similarly, assignment, we can have their attendance automatically, we can record. We can create the chat during the lectures, even chat for a particular concepts or topic choice. Even we'll be using many databases in our engineering activities. If there is a project and for a project related data we need to distribute, then we can create the database also. We can integrate external tools, feedback to students. We can create the discussion forum, glossary of term. Jitsi is actually the like a Zoom like video conferencing tool. We can create the lesson, podcast, questionnaire, quiz. SCORM is another standards for teaching learning. So we can create survey, wiki, workshop. So there are many such activities we can incorporate in our teaching and learning using this. Even this quiz, simply it is not nowadays say workshop. It is a group activities. So in a case of quiz, it is a in a case of quiz, it is a MCQ type or match the questions, fill in the blanks like. But workshop, it is a group activities. Similarly, if we take assignments, then assignments we can ask the subjective questions also. We can ask students to submit. And once they submit, our main concern as a teacher is plagiarism. So even here we can there are plugins available in a Moodle where we can check the plagiarisms. We can check whether students has copied or not. So if our institute or university is having a plagiarism check tools, that can be integrated in a Moodle. So there are many such uh, features available in learning management systems which supports implementing problem-based learning, active learning approach. So there are different services, a constructivist online learning environment. What was their uh, this is actually within the activities itself. I have demonstrated. Suppose if I go to survey, so what type of survey you want to have? Critical incidents, call as preferred and actual, call only preferred. There are many uh, uh, active learning, constructivist theories based study, and you can create the survey based on that. And one most important part that I'll show you. Say in case of NBA, managing calculating the attainment, course attainments, it is very important. And here, competencies competency framework. So here what I did is, say Bloom's taxonomy, cognitive domains, NBA graduate attributes, and program outcomes. Here this is for UG and this is for MCA. So suppose if you take this NBA, so these are the attributes. Similarly, if you take Bloom's taxonomy, so this is the Bloom's taxonomy cognitive domains dimension. So like this, you can add your competency, and when you create a assignments or any add some reference materials, what you can do is you can attach a competency to that. Suppose let us say my test one, I added this test one. So here you can see the competencies. So here I am added a competency, say remember, understand, and apply. Even I can search for competencies. I can add the course level competencies first. At the course level, what I need to do is I need to add the Bloom's taxonomy. I need to add the program outcomes specified by NBA. And once it is added, I can select the competencies. So once it is mapped here with this assignment, automatically when students respond to that, when students perform, suppose if I say that, so if students finish this simulation activities, then his the PO 2 it will be address, PO3 it will be address, PO4 it will be address, and PO5 it will be address. Then what I'll do is I add a simulation activities, assignment. I'll say that simulation assignment. And as a part of competencies, I need to add, first of all, I need to add the competencies at course level. So here, actually, particularly in this course, I have added 3 only. But let us add competencies to course, NBA attributes. So I have added these competencies to this particular course. Now let us add the activities and add those POs. Assignment, and I say I am giving a simulation assignment. There are many other settings. We do not have sufficient time to discuss all this. Now see, problem analysis I'm addressing as a part of this simulation activities. So as a part of this simulation activities, investigation is there. Design is not there. Modern tool uses, yes, I'll say it is modern tool uses is there. So like this, I can attach the competencies. It means the POs and Bloom's taxonomy, say cognitive levels we are addressing. Now, as a part of this, basically, this is a applications level, we can say. Now, once the students will finish this, then automatically it's CO attainment, PO attainment calculations. Similarly, I can specify the COs also here. As a part of this, I can add the COs, course objectives also. And I can say that this particular assignment, it is for CO1. Then once the course is over, finished, I can have a direct mapping of attainment of COs, POs by an individual student as well as whole class also. So it means that if I use effectively such LMS, learning management tools, it helps me to manage my resources, plan my teaching and learning process, and ultimately in assessment and calculation of attainment of COs and POs also using such a Moodle-like tool. Sakai and OpenIndex, they don't have such plugins directly. You need to program. But in case of Moodles, having this competency framework and competency mapping tools, and these tools you can use to calculate the attainment of your COs and POs and PSO. Now, in this browser, you can see when I right click, it gives me a pop-up. Now, in case of our examinations, we want that students should not visit the other sites. They should not be able to even open any other applications. And for that purpose, there is something called a safe exam browser. It is available. If I open the safe examination browser, I'll show you. Let me see whether I will be able to share it, because it being a safe exam browser, it is not, we cannot share it also. I'll try to share my whole screen. See, you can see this. There is a safe exam browser. It is a open source tool. Where you can configure what students can access. If you go to I have a safe exam browser running on my desktop, and what I'll do is I'll share my screen from another device so that you can see that. So you can pin to my screen. I am sharing my screen through that. Asfaq, can you? I have logged in with another device also. That there you can see CB
Yes,
is there.
sir. Yes, sir. Who we are, course categories. We can see.
Yeah, yeah. Huh. So that is the screen on my desktop where I have opened the safe exam browser. So just if you can see in a safe exam browser, uh, I cannot even right click. I am trying to right click, but it pop up, it will not be there. I cannot visit another website. If I want to do that, then I have to close this safe exam browser window. So it means that safe exam browser here within this itself, it will allow me to do that. So it means that the examination website, it will be accessible, but any other website I cannot access. Say page zoom, page search on page, it is there, but URL I cannot visit. I cannot press the escape button also. Suppose here you can see I am pressing the escape button. Escape button, it will not allow. If I say here I try to right click, then pop up, it will not be there. So it means that this safe exam browser tool, it will disable everything except examination window, and provide us interface to conduct the examinations without any disturbance. So here you can see now I have to quit only. I cannot do anything else. So just I quit. So that is the actually the feature of exam safe exam browser. So it means that if we have to, in real sense, if we have to implement this pedagogy practices we need to implement for NBA, then we need to use the online teaching learning tools and such other tools like safe exam browsers to conduct the examinations. So I'll stop here. I'll take a few questions. Any questions? Any?
Participants may ask questions here. Vilakhya sir was asking something, but Vilakhya sir, are you there? Uh, Sir, I had one question. May I ask?
Yes.
Sir, you have shown a safe exam browser, so that means that in this that our Moodle we have to link that safe exam browser. And is there any app from for that safe exam browser so student can use that app, or should he appear only on computer?
Students they have to download safe exam browsers
Okay,
and
sir.
take exams from that only.
Okay, sir.
2.5
Configure that our website it is accessible through that safe exam browser.
Thank you, sir. Any participant may raise the question?
Sir, in mobile it is possible, sir? If you
No,
take some examination, MCQ question related examination in mobile,
for mobile
it is possible?
not available.
Not
No,
available?
mobile it is not available. Yes, Mr. Niles. Mr. Niles.
Good morning, sir. Good morning, sir. Your session was very useful, and it explains instructional approaches, different instructional approaches. But we have not gone through this all details of this instructional methods. So can you provide supplements and case studies how we can implement this to attain those POs?
Sure. I'll share material to Asfaq and he'll share with you.
And can you elaborate once more in concise which instructional method will be very useful and it needs to implement a classroom must implement methods?
I'll suggest problem-based learning. You start with open-ended problem and run through the course.
Thank you, sir.
Any more questions? I think there are no questions, sir, and it was really a wonderful session. And you started from the shift and discipline, and we concluded to the online education tool and how we can justify our POs and COs using that Moodle platform and online tools. That was wonderful linking with that, and really these 2 hours was not sufficient to justify all that, but you covered it nicely, sir. Thank you very much for your time and giving us this session. Even though you are busy with many activities, but you spared some time with us. Thank you very much from Government Polytechnic Palanpur, and we are in need. We may need some guidance from you in future also. So we may approach you for taking your guidance and blessing. Thank you very much, sir. And thank you all the participants for our session. We will meet in the next session.
Thank you. Thank you. Bye.
Bye, sir.
Thank you very much, sir.